So far about, we had a talk on sort of very front-end UI focused kind of stuff, things that run in your browser make the user's life more interesting. We've just had a talk about Jupyter Server and other technologies in that space, the deep internals that might run somewhere else. So obviously there's communication going back and forth between these two sides, and so there might be some security implications to such things. And so we've got Joe here to give us a talk on security, hacking, cyber stuff in that space and what could possibly go wrong and what we should be aware of.
Yeah, so if you like the things we're talking about here, I'm not really going to be teaching any hacking, but we are teaching a class out of Black Hat, so you're welcome to come. All right, so from David's talk, authorization, that's awesome. I'm very excited about that, and I just want to plug it. Cool. So we're going to be talking about post-exploitation in Jupyter environments, and I'll define that a bit. My name is Joe Lucas, and the purpose of this talk is to help you understand your workflow or the infrastructure you're setting up from the perspective of an attacker to improve your defensive posture and awareness. Sure. There are no exploits in this presentation. There's no crazy 0 days, right? Everything I learned here, I just read the documentation, and the great thing about like open source stuff is if that documentation is not in Markdown, it's in code. So for background, I'm on the AI Red Team at NVIDIA, and so we have a couple of different lines of work. The primary focus is securing the AI products that NVIDIA builds. So we assess those and test those. And if you're not super familiar with AI security, I think the kind of canonical examples people are aware of is taking a picture, making some barely perceptible or maybe human imperceptible changes to the pixels and changing how it gets classified by a machine learning classifier. Another example would be self-driving cars, right? They're trained to recognize stop signs, but maybe we can put a sticky note somewhere on that stop sign and now it's not recognized as a stop sign and cars drive through. Those are examples of test time attacks, right? The model is already deployed in a service, and we're attacking it at test time. There are other types of attacks that happen during training time, and you can think of your workflows in Jupyter as being potential targets of these training time attacks. And then Cunningham's Law is that law that says like the right way to get an answer is to post something wrong on the internet and someone will correct you. I'm kind of hoping that happens in this talk, right? I'm fairly self-taught. This is all exploratory stuff, and I think many of you might know better things or workarounds or ways to defend, and I would love to hear about those afterwards, right? So even though I'm a red teamer, the job is to improve security. And so if you know ways to break these things or prevent these from happening, like I'd love to take those back. So let's kind of step back into what an operations process looks like for an offensive operation. So there's the exploit. That would be some sort of vulnerability. You could think of it like a CVE, or more often it's a misconfiguration. And that's kind of how the attacker maybe first gets onto a host or starts kind of interacting remotely. Maybe maybe a mental framework that most people might be familiar with is launching a Flask server in debug mode. If you launch it in debug mode, there's this console endpoint, and then anyone can execute commands through the console endpoint. So that would be an example of an exploit from a misconfiguration. We're not going to talk about exploits here. What we're going to talk about is what happens afterwards. So in security, you hear people talk about defense in depth, or you might have heard your security teams talk about assumed breach operations. A lot of security is focused on hardening this outer perimeter, and it ignores the GUI center. And we'll be talking about what happens in the GUI center so that we can improve our ability to detect bad things or respond to those bad things. And so some things that happen in post-exploitation are reconnaissance. So the attacker is going to get onto the box and they're going to look around and they're going to figure out, hey, is there anything valuable for me to take or valuable places for me to go? And they might establish persistence. So oftentimes that initial exploit is hard. It's hard to execute. It might be probabilistic or rely on other factors. And so often they'll build another way to come back onto the box if they get booted. They'll also probably see if there's some lateral movement. So great, they got onto one box, but maybe they're going to try and pivot because something more valuable is connected to this box, or achieve some kind of effect. And so that goes back to what I was talking to about training time attacks. So if I'm on a data scientist machine, I might try and modify their training data to impact the final product, and there are algorithms to do that, or modify their code. Okay, so now we'll hop into a demo. We're still good. I need to be a little bit bigger. Okay. So there are a lot of different toolkits attackers can use. Can everyone see that? Yeah. We're going to be using Sliver. It's just an example of a class of tool. And all of these tools kind of give the same sorts of functionality. They allow attackers to build an implant, so that's like the malicious thing that's going to run on someone's computer. They allow them to do some kind of rudimentary attack techniques, and then they allow them to control an operation and collaborate with their partners, because in kind of a more formal environment, there are multiple operators, and they might be handing off access or sharing certain things they've learned. And so here, the first thing we're going to do in this case is start a listener. So normally, getting code out of or something to call out from an environment is normally much easier than trying to call into an environment because of the way network routing works. And so what the attacker does is normally not on their own machine, on something they've procured, is they'll start a server listening for a call. And here, I'm going to just start a container that has Jupyter Lab running on it. I should have mentioned that most of this will be in the context of Jupyter Lab, but will also apply to instances spawned from Jupyter Hub. And when this container is built, it's going to execute our arbitrary code that was just like in the Docker file to pretend we did an exploit. And so when that server started up, we can see back on Sliver that a session started. And these frameworks are built to handle a wide variety of sessions because maybe you have access to a dozen machines that you need to kind of coordinate your operation. And so we're going to go interactive with this session we just established. And so when you see rough Bakeware up there, that's just the name of this implant. And you can think of us basically as having a special kind of shell on the instance running the Jupyter server. So that's what we've exploited in this instance, or what we're doing our post-exploitation on. Attackers are going to try and figure out who they are. So imagine back to that Flask scenario. If you're just executing commands through a Flask console, you probably don't know a lot about the host, right? And so you're going to start trying to figure that out. And this tool gives you kind of the framework to start doing that, to start doing the reconnaissance step we talked about, right? One thing that we always look at is environment variables, and this kind of gets to the first element of the juicy center. So a lot of applications expect, or people keep their secrets in environment variables. And so if you've worked with MLflow, an experiment tracking platform, if you enable password login for MLflow, the recommended way to do that is by storing your credentials in environment variables. And so here, an attacker with access can obviously dump your environment variables, which is why a lot of product security teams are going to tell you that's not where you should be storing your secrets, because it's kind of globally accessible. It's not just accessible in the context of the application. I mentioned that something like Sliver, these kind of C2 frameworks, are designed for collaboration. So they have ways to like store information. In Sliver, it's called loot, right? And so we can just say, oh, look at this thing we found. We can store it. And then later on, imagine somebody I'm working with 2 days later realizes they need an MLflow cred. here, they can look through our list of loot and fetch that cred, right? So this is just a way that attackers are going to collaborate with each other. We'll also look at the directory, and if a netstat didn't kind of tip us off that it's Jupyter, looking at the local directory will. And so I like to look at the IPython directory. We see there's only a default profile. And I think this is a really interesting directory to find yourself in. And it's one that I encourage people to audit more. So we talked about persistence and finding a way back in, right? Any Python file in the startup directory is going to get executed. And so that might be a more reliable way for me to regain access back to this host afterwards by just putting something in there. The history file, right? If you're in a notebook, and this is the way that you're storing your credentials or saving stuff. When I've been in these environments, we are always going to dump your SQLite history, right? And then right, so after we've dumped the history, we're going to be able to get that credential back because you entered it in plain text, which then got saved in plain text in the SQLite database. So that's another way to think about when you're entering this secret material, you should be using a key store like Vault. Let's see what else. Yeah, the next thing we look at here is the runtime. Whoa. I don't know what just happened there. So if you look in this runtime directory, you have kind of everything you need to interact with an instance, a running kernel. So you could also run this or get the token by running something like Jupyter server list. But because I actually didn't prepare this demo on this M1, I had some issues doing that. Right, so now from a different browser, can that be made bigger? Right, I have the token and I can connect to this. And from this browser, or from this instance, right, which is back on the attacker machine, I can write things, and then from, what we'll call the victim machine, right, I've influenced that runtime, which is, again, is like a way that I might impact someone's training workflow. Now, the method I just used, sometimes I get kind of a warning here about the notebooks being like out of sync and out of state, but I don't always, and I think it has to do with how often the notebooks save. Okay, but let's assume maybe we can't do that, probably because of how the network is configured. The next technique I'd use is grabbing this kernel JSON. So just like I downloaded something from the victim to the attacker machine, I can also upload things. I can drop to a local shell. Attackers care a lot about OPSEC, operational security, like what kind of evidence they're leaving on a machine. And so there are guardrails built into these tools, right? Like, so if I drop to a local shell on the host, now like everything I do is going to be logged, which probably isn't great. But it's a demo. So that kernel has everything you need to execute code locally, and so well, I closed out of it, but it might actually still work. So I never, as the victim, ever created a variable called bucket, but from that victim script, all I did was create a Jupyter client, connect to using that kernel file, and then ran code. And this silent equals true means that that code didn't increment the little execution counter you used to seeing increment on the left, and that code is not in the SQLite database. So something to know. All right. So I think lesson one, kind of that I'd like you to take away from this, attackers like to live off the land. They don't want to move things over the network. They don't want to leave artifacts. They don't want to leave history. And that's kind of what they refer to as stealth. And Jupyter makes it really easy to do that because it's such a powerful tool, right? All the same reasons we love it as data scientists make it valuable to an attacker because it has network comms. There are environments laying around everywhere. So if I need the requests library, I bet you I can search through your Mamba environments and find the request library, right? I don't have to install anything. And maybe I don't even need the server you have running. So in all these examples, I used or interacted with a specific data scientist's workflow. But like if I can just launch Jupyter server with allow root on the broadcast, you know, like I can just use it in a way that is helpful to me. Lesson two, I think you should take away is the blast radius. Think about where your Jupyter workflow fits into the grand scheme of things. Remember that, like, my perspective is product security. So your workflow probably fetches something from AWS or connects to databases. It probably pushes to an artifact store or results in some final product. And I think as you're thinking about your security context and footprint, you should think about all those other things that you impact that maybe you're not necessarily running. Do your best, right? I think I'm really interested in auditing environments and started building some tooling around that. And so if that's something you're interested in, please talk to me. When possible, just create some sort of boundaries, right? Introduce friction. I'm not an absolutist with security. I think anything you can do to make it harder is a win. And so if you containerize things, there are the number of attackers who get, a container should not be a security boundary, and many places are going to tell you that, right? It should be a hypervisor, it should be a VM. But the number of attackers who can actually break out of a container are like much fewer than the number who could just execute code on a host. So a container is friction. And segment your network. And then permissions are a pain, so is credential management, but they exist for a reason. And so you may be thinking like, oh, I can run this code to have my secret key, and then I'll just delete the cell before I commit it into Git, and like, that's fine. But know that if I land there, I'm gonna dump your SQLite database and I'm gonna look for it. So some conclusions. It's an awesome tool. I love it. Use it responsibly. The thing that is most surprising to some of the people I work with is that like people want to attack them, and they're certainly out there. I think the defaults in the ecosystem are a great compromise between usability and security, right? Like, we have to decide how can we build a tool that makes it easy for people to get started and a tool that can secure enterprise workloads, and that's really hard to do. I think the defaults are really good. So when you find yourself overriding those defaults, do it with care. I think the sharp edges are documented, but sometimes that's not good enough, right? So I've seen multiple users working together on one Jupyter Lab instance. If you go to the documentation, it says, this is not the multi-user solution you're looking for. You're looking for Jupyter Hub. But, you know, people are going to do what they're going to do. And then, especially for the Jupyter kind of developers around here, people who want to contribute to it, how are we helping defenders detect and perform incident response, right? What artifacts are we leaving? How are we ensuring the integrity of those artifacts so that if someone thinks something bad happens and an incident response team shows up, they have something? And I think that's a hard problem right now, and there aren't a lot of incident responders trained to perform that. And then a couple of times during this conference, people have plugged like, hey, there's this calendar, you can just show up. I'll say that also. So a couple of months ago, I got like interest in Jupyter security. I fell down this rabbit hole. I was opping on Jupyter targets. And I like looked and I was like, oh, there's a security group. Like I should just show up to that call. And I did, and they've been incredibly welcoming, and it's been like really a great experience for me. So even if you aren't quite sure how you want to contribute, I recommend you just hop on some of those calls. I think you'll find a way. Okay, are there any questions?
The back.
Thank you very much. I have a question to the very beginning.
Okay.
In the way how you attacked actually the Jupyter environment with the Sliver. Like, I mean, so you had to be within the singular network, or how does it work?
Yep. Yeah. So the behind the curtains, the way the real misconfiguration here is that instance is running with IP quad zeros, right? It's running on the broadcast domain as opposed to localhost, which is the default. So when I say override the defaults with care, that's one. And so a lot of times I will find that because people want to be in the browser on their local host, but need access to some compute resource. And so they haven't done network segmentation well. The server's running on broadcast and they're not VPN'd in, or they don't have traffic allow listing. But yes, that's exactly right.
Fantastic.
Yeah, maybe just a follow-on question. So obviously in an enterprise setting, you have like a bunch of restrictions.
Ideally,
yeah,
yes.
Exactly.
Don't assume that, yeah.
Sure. So is the real threat in this case like an outside attacker, or is it actually someone within the network, maybe an employee who's disgruntled or something? Because it's a very different scenario then, right? If people have, like if they have allowed access to kernels, in which case, like, I mean, I guess you're using C groups and stuff to isolate it, but the balance of the two is a very different game.
Yeah, I agree. We do see outside attackers who have gained a foothold in the network then look for these assets from kind of inside the corporate boundary. So I think you can bundle that along with insider threat. Those are kind of the same in terms of the visibility they have of assets. But then we also do see these exposed on the public internet, a lot of times through people using things like this hosted by cloud providers.
So I'll just comment on that extension. He's like, oh, that wouldn't happen in a production environment and the users would be safe. The wonderful thing about the Jupyter ecosystem is the users can be the deployers and the operators of these systems really easily, and we have no idea what we're really doing. So here's my question. In terms of not the professional people who are doing this, but the rest of us who are using these powerful tools, this half-hour talk seemed way useful, more useful than any kind of security briefing I've ever received from any institution about your password needs to have so many letters, change it every 3 months, please. Where is this talk, and where should we be pointing those advanced power users, people who have to self-manage their operations, who really need to know that they're not wearing any clothes? Where do they go for this kind of?
Yeah, I mean, I was hoping I just gave it, but
no. I'll point it to your
no.
talk.
So part of my personal interest, right? So my first career out of the Army, I was a data scientist, and then I've pivoted into security, and now I'm blending the two. Right? I've spoken at many security conferences, and I've seen many talks like this at security conferences. But part of what I'm trying to do is bring some of this into the builders and the people running the code to just increase some awareness and some sanity. Yeah.
Thank you. That's fantastic. Any other questions? Yep, one in the front.
Thank you. I have a last question. Is HTTPS protect me if I make a certificate? So using Jupyter Hub or Jupyter Lab?
It protects you in certain ways, right? I think you have to think about risk as an onion. It protects your network communications. And no attack here I showed involved snooping your network communications. So it doesn't protect you from most of the things I showed you here today.
So using the same tool, it will be in a clear mode? or hashed mode? What you saw here. Like
most of these
password.
things I authenticated the right way, and I didn't snoop anything over the wire, which is what HTTPS is protecting you from.
Thank you.
Hi. Do you think Jupyter is a good tool to teach security?
Yeah, so there's an incredibly active community of security users of Jupyter. So Mythic is another framework similar to Sliver that I just showed. And this past week, they released a version 3 that ships with Jupyter Lab and a bunch of notebooks for analyzing security data. Last year at PyCon, there was whatever those little things are where you run off to a room, full of security users, led by the Microsoft Mystic team. At AWS, they have automated runbooks to help with incident response. So there are a lot of security users of Jupyter.
Fantastic. Any further questions? Well, one at the back. Oh. One last question for the session.
As long as you don't need my screen, I unplugged it.
Yeah, I was wondering what your thoughts on are like protecting, as an administrator of Jupyter, like protecting yourself from the users against preventing them from doing these things. Like, you can assign all the security trainings you want, but often a code enforcement solution is sort of more robust, right?
Yeah, that goes into what I was talking about with auditing. Like, I would love, and I'm working to build some sort of solution where I can say, this is the gold standard for what a Jupyter environment should look like. I'm going to connect to every Jupyter environment. I'm going to scan their config. And if they're out of violation with this, I'm going to investigate or quarantine or whatever.
Cool. Well, let's thank the speaker again.